In this video here, we're going to make use of the second part of example number 8 in the lecture notes to learn the algorithms of using Newton-Raphson methods to find the solution of an equation. At the same time, we try to learn some calculator skill to make the calculations even simpler. Okay, so according to these questions here, by taking x1 equals to 1.7 as the first approximations, find the roots of the equation x minus 1 equals to sine x correct to 3 decimal places by using Newton-Raphson method. So in these questions here, the first approximation is already given. They want the final answer later for the solution to be 3 decimal places. And how we happens to solve according to Newton-Raphson method, let's see. So by using Newton-Raphson method, I need to refer to this formula here. xn plus 1 equals to xn minus fxn over f prime xn. And by observing on the formula, before I can start the calculations, I need to find out what is the corresponding f and also f prime in this question here to solve the equation x minus 1 sine x. So we begin from there. From the equations we have in the questions, I would like to find out what is my fx. So in order to obtain the fx, we just need to have all the terms rearranged on one side. For example, I rearrange the sign to the left hand side, and as a result, I suppose I have the answer. X minus 1 minus sine equals to 0. So this is the result I happen to obtain when the time I rearrange the sign over the other side. Of course, it's optional that you can rearrange x and minus 1 to the right hand side. But let's say in this case here, I rearrange in this way. Then, from these new equations here I have for rearrangement, those parts that now I highlighted in green, which is the left hand side of the equations, I'm going to let it be fx. And of course, once again, the condition is that I must rearrange in such way that one side is equal to 0, the other side with the rest of the term. All term on one side, then equal to 0. Then only I can start to have my assumption for my fx. In here, I let fx equals to x minus 1 minus sine x. Then continue. I need the f prime, so I differentiate it. I have f prime equals to 1 minus cos x. So reach up to here, I happen to able to fulfill the requirements on the Newton-Raphson methods. Then I can start to do my calculations for it. And let's see. So according to the questions, you happen to find out that the first approximations is given as 1.7. Therefore, we notice that x1 is equal to 1.7. And the next thing what we're going to do is that we start to apply this formula here to calculate our x2. So by referring to this formula, the idea is just as simple as the xn plus 1 is the current x that we want to calculate. The xn is referred to the previous x. So in this case here, x2 it will refer to the current calculations. x1 will refer to the previous result that we're going to do for substitution in our function. And in this case here, what we're going to do now is that according to the formula, we will have xn, in this case here will be x1, minus with the division of, we substitute 1.7 into fx, we substitute 1.7 into f prime in such way. Then we're going to press calculator to get the answer. So before you press all this 1.7, so on and so forth in your calculator to get answer, please take notes. Today we're going to learn a calculator skill that make this process of calculation become faster than what you usually do. Where what you need to do now is that you need to key in the following functions into your calculator. which is actually corresponding to the xn minus fx over f prime. It's just that we neglect the n in our writing here. So this is the function that I want to key in into the calculator. Again, this is happen to be corresponding to this part that I want to key in the calculator. Just that we neglect the n. So now let us key in the functions. But before that, take notes. The questions here regards on trigo. So for regards on trigo, for safety purpose, please kindly do set up on your calculator. We set into radian mode. So my calculator, the radian mode is being set up in the way that I press shift mode, then I go for radian. So if you're using some other calculator, then it depends on how the setting is being done. Then now, next what I'm going to do is I'm going to insert in these functions accordingly in x. So I have x minus fractions, x minus 1 minus sine x divided by 1 minus cos x. Once I'm done with this function I key in, next I'm going to do is that now I want to evaluate x2. I want to evaluate x2 by substituting x1 into the function. So therefore now, to calculate x2, I need to substitute x1, which is 1.7. And the way I substitute is press the button, calculate CALC. So it will appear x question mark. The value here appear is the previous value that I happened to insert for x. We can just ignore this value here and proceed to key in the value we want. So now we want 1.7. We are substituting 1.7 to calculate x2. Once I get my 1.7 in the calculator, I press the button equal. Then the corresponding result came out will be corresponding to the result for x2. And in this case here, the question requests us to have the final answer correct to 3 decimal places. So by right, in our calculations, we just need to have 1 extra decimal places. So again, answer request for 3 decimal places. Then we just need to give our answer in 4 decimal places in calculations. And as a result, if you refer to the calculator here, if I want to have the answer in 3 decimal places to write into my solution, I will round it, 4 decimal places, I will happen to have 1.9584. Again, final answer need 3 decimal places. So in our calculation, we happen to give 4 decimal places. So the answer will be 1.9584, where I round off and get this result. Next, we proceed with our calculations. After we get x2, maybe you can try to check the 2 results that we have, the first approximation and your first iteration. This step here, where you use the Newton-Raphson formula to do calculation, is what we call as the first iteration. The very first time you use the Newton-Raphson formula to solve the questions. You have 1.9584. We try to compare these 2 results when the time you round off into 3 decimal according to the requirement. Do they happen to have the same answer? But very obvious, it's not the same where this one just 1.7. When this one I round off to 3 decimal places, it will be 1.958. It's totally different. So if it's not happen to be the same, then I proceed with the next iteration. The next iteration will happen to produce x3. And how we happen to get x3 here? By substituting x2 into the Newton-Raphson formula. So I substitute this one according to Newton-Raphson formula. This is the framework that I should have. And what is the result of this framework here? We can just calculate easily by using calculator in such way that refer to your calculator. In the screen by right, you still have this function in. Then what you do next is that you just need to press the button calculate. 1.7 is the result that just now you insert to calculate x2. Now, in order to calculate x3, I want to insert the result from x2, which is 1.9584. But take notes, guys and girls, we are not going to key in 1.9584 like this manually, but instead we're just going to make use of the button answer A and S here. We press it and then press equal. So this is the result that we happen to have when the time we substitute x2 into the functions. And we have it as 1.93475. And I want to keep in the display on my calculations here up to 4 decimal places. So I will have 1.9348 as the result. Then once we have reached until these solutions here, once again, we check, do we happen to achieve our answer? Can we happen to fulfill the stopping criteria? So round off to 3 decimal places according to the requirement of the question for final answer. I have 1.935. And you compare with the round off value from x2. You find out that again it's not the same. Therefore, I need to go on further for calculations. So I need to go for the iteration for the third time. The third iteration will give me x4. Where x4, I will substitute the result from the from x3 into Newton-Raphson formula. So this is the framework I have after I substitute. Then what I do the next is that I'm going to calculate using my calculator to get answer for x4. And how I happen to do that again, with your calculator still with this screen here, we press calculate, we insert the answer, and then equal. So I have my result 1.93456. So I keep the answer up to 4 decimal places in my calculations here. It will be 1.9346. And up to here, once again, we check, have we fulfilled our stopping criteria? If I round off into 3 decimal places, I have 1.935. Now you see the round off value is happen to be the same. Therefore, we shall stop our iteration. We no longer calculate x5, but we're going to end our answer x equals to 1.935, which is the round off value that we found just now. So therefore, this is how we get the solutions for these questions here by using Newton-Raphson method.